the approach of outlier handling using IQR technique, interquartile technique that we just saw on the whiteboard. So very first thing that we are going to see is the DF, the data frame. This data frame is user's data frame, and it is having a column which is age. So specifically, this technique is applicable for numeric data and when you have univariate distribution. So that means like we are focusing on a single feature right now, and we are not talking about multivariate thing. So we are talking about age column. So we have DF, and within DF, let's say we have df.age, and when we run it, we can see the data. Now df.age, we can find out the max value, and we have 73. When we want to see df.age.min value, the minimum value is 7. So we want to find out outliers in this data set. So in order to do that, let's use NumPy, and we will make use of a method called quartiles. So there is a method np.quartile. So this method, if you just do question mark, and then you will see like it basically expects data, and it expects the values between 0 to 1. So we want 25th, 50th and 75th. So we will be passing those quantiles to this particular method. So very first argument is the actual data. So actual data is df.age, and it is a series. So I want to get the NumPy array. So I'm extracting those values and I'm passing it to the np.quantile. And then we have the various values which are like 25th percentile, 50th percentile, 75th percentile, and then 100th percentile. So I just passed all these values here, and I will store it in some array. So I'll just use q equals to this, and then I run it. And when I show q, then it will be like this. So it is telling me like the minimum value, the maximum value, and then in between 25th percentile is 25, 50th percentile is 31, 75th percentile is 43. So in case you want to see this, you can always do df.age describe. So using this, you will get descriptive statistics, and you can see all these values are actually matching with what we just got from the NumPy. So pandas output and NumPy output both are matching. So you can see we have minimum value 25 is the 25th percentile, 50th percentile, 75th percentile, and maximum value. So now we can even calculate the median or mean. So we can see the mean value. Mean value is this one, and this is the mean value. And if you want to see the median value, then you can get it from pandas. We have the median value, and it matches with the 50th percentile. So now we are able to get the 75th percentile and the 25th percentile. And if you go back to the whiteboard, so here we were discussing about Q3 minus Q1. So that is, we want to find out IQR. So in order to find out IQR, we will be writing here IQR equals to Q3 minus Q1, right? And once we do that, we will be able to get IQR, and we can print IQR. What is the value of IQR? We got 18. So this is the value of IQR, and we want to find out what is the lower limit. And lower limit in our case is Q1 minus 1.5 times the IQR, and we got the lower limit. And similarly, we can write down the upper limit. So this one is upper, and here we have Q3 plus 1.5 times IQR, and we can print the values of lower limit, and we can print the values of upper limit. So we see that lower limit is -2. That means 7 is still within the lower limit, so we are not having any issue. But upper limit, you see the maximum value is beyond that, so we are expecting the outlier would be maybe at least 73 should come. Any value above 70 will be outlier. So let's write a method with generic method through which we will detect outlier. So I'm just writing outlier equals to empty list. So all the outliers, I want to include it in this array. So I want to detect outliers, and I want to keep it in a separate array. So let's do for x in the values that we have. So we have this NumPy age. So these are the values. I'll just copy this particular, and I will paste it here, and I will write within this like if x is less than less than lower limit, or x is greater than upper limit. So in both cases, these are outliers. So I'm saying outliers dot append. So this is the array, and here I'm passing x and I'm running this loop. And when I print outlier, then I got 73, which is basically an expected result that I was expecting, because like user that we have, the upper limit that we calculated was 70. So the users that we have, like one user having age 73 is an outlier. So now quickly we can plot box plot. So we have this feature in the Seaborn, and we can just use sns.boxplot, and we can pass this particular age df.age and this particular feature df.age within this box plot. And when you see the box plot, it is showing the outlier, which is 73. So I hope the theory makes sense now, and you can correlate with the practical and how do we detect outliers. So this is about one approach of handling outliers. We will also see another approach of handling outliers.